Okay, so now we're working with proportions, same kind of deal. We want to check the conditions and make sure we're doing the right test. Um, we are told that this is a random sample, right? Right there. So that's interesting enough. I'm not interesting. That's good. And this is about, I see 85% of at least 85% who have graduated from school have received a college degree or are in the process. Um, so then went out and did a random sample of 60 former graduates and found that 647 had received a degree or enrolled. Does the data contradict the school official's claim? So I see a quantitative variable. Actually, it's a binomial variable, right? Yes, they got a degree. No, they didn't. And uh, and I see a fixed number of trials, right, of 60. I don't think it changed. The probability changed. See, I'm trying to make sure it's a binomial distribution, right? 'Cause that's part of the requirements. I don't see how catching one person, one graduate, would affect the probability of the next graduate being uh, uh, same probability, and uh, and so they're independent, and there's uh, independent, and the probability doesn't change from person to person. Now we just got to make sure we get a normal distribution. And how we do that is we do n times p has to be bigger than 5, and n times 1 minus p, or q, also has to be bigger than 5. If that's true, if we were to graph all the possible outcomes of 0 out of the 60 to 60 out of the 60, we'd get a nice normal curve. Um, but let's see if this works. So we do what's probability of success is 0.85 times 60. Well, yeah, I mean, 10% of 60 is bigger than 5, so 85% would be 2. And then 15% of 60, 1 minus 85, well, as you said, 10% of 60 would be 6, so that's bigger than 5, and 15% is bigger than that. So both of these are bigger than 5. Yes, we're good to go with a one prop z-test, a one proportion z-test. Okay, so make sure you show that setup. I'm not saying you do this every time, but if I ask you that on a test and I say, sure do this stuff, you're going to want to do it. Or I've got to dock points if you don't, and I'd rather not do that. Well, the other thing about checking the conditions, this could help you do the right test. I mean, 'cause we don't want you to do the wrong test. I mean, people do Z test when they should be using T test, or vice versa. So that'll save you some problems. So let's see. Then what's the claim? Oh, well, right here they kind of tell us that right there. So that's the claim. Um, and does the data contradict this school official's claim? I'm thinking I want to going to make H1 be the claim here. So HO. Now I'm on proportion, so I'm using a P, not a mu. That equals the school official's claim. And then the other question I want to ask myself is, I say I'm trying to decide whether it's a right-tailed test or left-tailed test. So what's 47 divided by 60? 47 divided by 60 is 0.78. So 47 divided by 60, because that's the sample proportion. That's 78%, or 0.78%. 0.78, 0.783. That's less than 85, so I think I'm safe going with a left tail test. Notice the other thing I haven't mentioned. Notice you never put the sample distribution mean or numbers in for your hypotheses. You always have some value that you're trying to prove or disprove. Okay, that's what goes in both of those HOs and H1. Let's see. So now we're gonna run the test, I guess. What do I got? I've got n equals 60. I know x equals 47. I guess that's all I need. So yes, I could do a calculator. I mean, I could do this all by hand using formulas like Dr. Stevens showed you. We can also use Rossman Chance. Just select that you have one. You select the drop down and go one proportion. You're going to type in the sample size, type in the 47, and click calculate. And then you got to come over to the highlight test of significance. And we did see I used the exact same hypotheses. Whoops. I used the exact same hypothesis that I wrote over here. That's why it's important to write those hypotheses. Then press calculate, and you get the test statistic. You get a p-value. We want to record those. I want to see those. You could do a screen capture and highlight them, and that'd be okay. But don't post this in here because I want to know you know what you're looking at. And then let's see, what do I do? So p-value is 0.07, alpha is 0.10. Wow, that's a big p-value or a big level of significance. So 0.07 is less than 0.10. You don't usually see critical value or a alpha that big. So in this case, though, we're going to reject HO. So we'll reject HO because that p-value is smaller than the 0.1. So we'll reject HO. Now we're going to make a decision about it. Now, I didn't say this, but I think I said I wanted to make H1 be the claim. I think I said it, but I didn't write it. Because does this data contradict the school official's claim? I know somebody's trying to run down the school. I don't know. Really, because it's a matter, what are you trying to show? In this case, it sounds to me like they want to show that it's not equal to 85% or higher. So let's see. Now gave the test statistic. I rejected HO. H1's the claim. So we said HO was the claim. Let's see. We said H1 was the claim. H1 was the claim, and we rejected the null hypothesis. We rejected HO. So we're going to phrase this as let's see. Let me do this. So the data supports the claim that, you got to write that in, and then what is it that? Let's see. Now I don't remember how they worded that. Let's see. So we said that does it contradict the school official's claim? So I think that's what we made be the claim. So the data supports the claim that the school officials are wrong about the 85% number, or that the data supports the claim that no, less than 85% of students graduate from the school are going on to get a postgraduate degree. Okay, so you see how that works? And I didn't write that out, but that's what I'm hoping you can do. You can do something. Rejecting HO is not enough. You got to be able to say what it means in the terms of the context. Okay? I mean, you could just you could have done H1 be the claim or HO be the claim, and we rejected HO. So then we'd do that. There's enough data support to justify the rejection of the claim that the level of the rate of graduation, the rate of advanced degrees is less than 85 or more than 85%. No, it would say it's less than 85%. So we're rejecting that claim. Okay, I hope this helps.